I am Kevin Devecioglu. I am the Managing Director of Bimser International. Today we have great panelists with us to cover the subject of Industry 4.0, smart manufacturing, and set of future workforce, how it'll be in the digital age. So we have very important subjects to cover today. First of all, I like to start with a brief company presentation of who we are and what we do, and then we'll continue with Industry 4.0 and Cloud ERP technology with Roger Hoyt from Integrated Data Technologies. So a brief overview of what we do. And who we are. We are Bimser International. We are an enterprise maker since 1998. We believe in simplicity, and all of our products are to simplify processes of companies. That's what we believe in and how we position our company. As a company, we are a group of companies. As a matter of fact, and our parent company and our development center is in Istanbul metro area. Since we are an enterprise software maker. We have another company in Europe. As Bimser International, we are located in New York. And Bimser Europe is located in Netherlands for our European sales operations. As a group, we are about 150 people. And we are a certified SAP vendor, a Microsoft Gold partner, and an Acumatica independent software vendor. When we look at our products, we have 4 products. We are very focused in what we do. EBA is our workflow and document management platform. Bheem is our asset and maintenance management. So QDMS is our quality, risk, and compliance management software. And Ensemble is our business process management software. So when we look at our products, Ensemble is more of a managerial tool, where it is KPI management and balance scorecard management capabilities. EBA, Bheem, and QDMS with workflow, asset and maintenance management, and quality management, they are to automate processes of companies. All of our products, they can work standalone. They can be integrated to any ERP, any CRM platform available in the market. They can work on-premise or on cloud servers, and there is also mobile apps available for each of our products. When we look at what we do, as you see on the screen, we have done many different projects, and we have many customers globally since 1998. And these figures show how many projects we have delivered and what we have done so far. As you can tell, we are very experienced in enterprise software development and implement. Also, a little bit information about our customers, who we are working with in general, and some of our reputable references. 3M, United Nations are some of our references. For instance, United Nations is using EBA for refugee tracking. ArcLight movie theaters based in California, they use EBA to manage their purchasing operations. And as you can see, we have references in pharmaceutical industry, banking, and manufacturing, and also in automobile industry. In a nutshell, that's who we are as Bimser International, an enterprise software maker. And that is basically what we do briefly. So right now, I like to turn it to Roger Hoyt from Integrated Data Technologies. He will be covering cloud technologies and Industry 4.0 in general. As I said, we have a great lineup today, and I'd like to also thank you for your time, and looking forward to coming slides. Roger, would you like to take it from here?
Thank you, Kevin. And thank you, everyone, for joining us here on this Industry 4.0 panel discussion. I'm delighted to be part of the panel, and I just want to start by introducing my company. My company is Integrated Data Technology. We are business technology consultants in the field of ERP, CRM, implementation and integration services. Next, please. Some of our core solution providers are Acumatica, which is one of the top cloud ERP systems, Bimser, Sage, Scanco and Amvazant for predictive analytics. Next, please. Some of our customers that we serve around the country are listed here. They cover quite a broad cross section of industries, including pharmaceutical, manufacturing, food, and service related companies. Next. So today, Industry 4.0, the smart factory. Well, let me begin by saying to you that you're going to hear these terms used interchangeably, and basically they mean the same. Uh, Industry 4.0 is the European acronym, and here in the Americas, you're going to hear smart factories or smart manufacturing. They both basically mean the same. The whole concept of Industry 4.0 was started in Germany and is considered the fourth major reset of the Industrial Revolution. Next, please. To start, we must take a historical look back as to where we came from. And this goes back to Industry 1.0 in the 18th century, which was promoted by mechanical, basically powered by water and steam. Fast forward about 100 years to the 19th century, with the advent of electrical energy, we saw the assembly line come into play. Moving forward another century into the 20th century, we entered Industry 3.0, which was basically the introduction of automated processes via computerization. And here we are today in Industry 4.0 in less than 100 years. So you can see that the time with computerization, the time frame kind of contracted quite a bit. Next, please. What is Industry 4.0? Well, the whole term can be summed up as the ability to collect, share, and use information in a productive manner that make better decisions and to decentralize that decision making. In the current state we are somewhere in between the tail end of Industry 3.0 and the beginnings of 4.0. Next, please. So, with Industry 4.0, technologies that support it. And I just want to go through it because it's very important that we understand the whole concept of Industry 4.0. And it starts by surrounding itself by this notion of cloud computing, meaning that we are on the internet, we're connected, our devices are connected. Next would be the ability to have mobile technologies. We no longer are tethered, we need to be on the move all the time. Third, we have machine to machine, meaning that machines communicating with other machines and sending information back and forth. Next would be the advent of 3D printing. A lot of people look at this and go, well, how does this figure? Well, think about it that with a 3D printer, you can move from concept to production in a very short while. So that's the importance of 3D printing. The next is advanced robotics. As we saw in Industry 3.0, robotics was big. Now, advanced robotics is even doing much more than it did back then. With all of this comes the advent of big data. And as you know, there's as much data produced in the last 10 years as being produced prior to that. And with data means nothing. It can be analyzed and put to useful uses. The next thing is what we all hear, Internet of Things. And when we think of Internet of Things, most people think of like the Amazon Echo, where we speak to it, it plays a tune. But in manufacturing, and it's referred to here as the Internet of Things, it's where we communicate machine to machine, passing back and forth data, consuming and producing data. The next aspect would be RFID technology. Think of it that we are able to produce product and trace its origins using this technology. So you can think of a machine part that is out somewhere with RFID. We can identify where it's being used, when it was produced, and so forth. The next would be cognitive computing, which lends itself to predictive analytics and preventative maintenance. And lastly, and the most important topic, is that of cybersecurity. We are on the internet, it's the most important thing. We are consuming data, we're producing data, but we need to make sure that that data is being delivered or accessed from a secure source. Next, please. So, what are the benefits of Industry 4.0 on the smart part? Well, one of the first and foremost benefit is improved productivity. Next, what we're seeing is an enhanced manufacturing process with great flexibility. And third, and this is a very interesting one, is safety management. If you think an Industry 4.0 factory, there's less humans in the factory. And think about it, if you're running a lights out factory where no humans, that means there's a less chance of accidents happening. And I'll tell you a story that I heard the other day in which one manufacturer said that due to Industry 4.0 and the automation in his manufacturing process, he was able to save money because his insurance went down and he was able to use that savings for the of his employees. So it was an interesting concept of what safety did in that particular interest. And lastly, in Industry 4.0 is the access and the consumption of data across the whole ecosystem. Very important because in the Industry 4.0, data is produced and consumed and makes it more efficient. Next slide, please. What are the automated system processes in Industry 4.0?
Perjury and lying under oath that he.
But first of all, if you think of the process, you have on-machine sensors. These sensors and actuators are constantly gathering information about the machine and able to tell its state. And you can think of this in the old days where you had an assembly line, and I'm going to use the example of a bottling company, let's say a soda bottling company. You had different sizes. Every time you need to change over from one size to another, that led to downtime. Within a Industry 4.0 environment, these sensors are able to adjust and automate the machine to accommodate such changes. Next, we go to machine connection. And this is very important in a 4.0 because you have now intelligent sensors and actuators feeding data to each other. So in a case like, and I'll use the bottling case here again, let's say the machine that is capping the bottle ran into a problem, it could signal to the machine ahead that is actually labeling the bottles to say, hey, stop your production, I have a problem, thus holding up the process. So there's no more overproduction in any stage of the production. The third aspect would be machine to back office. Very important stage. In most 3.0 manufacturing processes, there is a disconnect between the MES systems and the ERP systems. In a 4.0, this is all connected, and therefore information is fed to the ERP system as stuff is produced. One of the biggest lags is when an order comes in present day, getting it down to the machine, getting it down to the manufacturing floor. Think of in Industry 4.0, an order comes in on the web, it's immediately entered into the ERP system, which can now look up and source if any raw materials are needed to be purchased, issue that purchase order to the most relevant supplier, get an estimate of the time that part or raw material is going to be in the factory, which in turns can update a scheduler and put that to production, therefore producing inventory just in time. One of the clear benefits here of Industry 4.0. And lastly, factory to factory connection. If you are a large multinational or multi-plant manufacturer, if you're having a problem in one plant, the machines in those plants can communicate with your other plant elsewhere and offload production, which means that you never or delayed in producing because you can communicate elsewhere and say, hey, I have a problem in plant A, plant B, could you pick up the slack and make those production, continue the production. Next slide, please. So what is the constant here in Industry 4.0, smart factories? As you can see, as we talked all along, here's everything about cloud computing, the internet. The internet is a vital part of this whole concept, the constant communication in-house, communicating with our supply partners, communicating with the logistic partners, all circle around cloud computing. So with that, I would like my portion of the presentation. Thank you very much. Kevin?
Thank you very much. Thank you, Roger. Well, it's been actually great for us to learn about Industry 4.0 and the concept and how we need to actually look at it. So it's been actually very educational for us. The great insights. Thank you very much. Much appreciated. Right now, what I like to do is that I like to turn it to Chris Colicchio from Techworks Consulting. And he'll be covering smart sensors and predictive analytics part of Industry 4.0. And I like to let him continue if that's okay. Chris, would you like to continue from here?
Sure. Excellent. Thank you. So thanks for joining. Definitely excited to talk about an area that we see in our organization as really a future and a transformation, not only from manufacturing, but for a lot of businesses, across their IT landscape and how they can take advantage of the IoT in general, but more specifically, some of the sensors and stuff that are coming out that we're already starting to see. So, and be able to predict their business. So, first off, I think there's a slide. You can go to the next slide. It's a little bit about myself and Techwork, who we are. We do consulting IT services. We also have an infrastructure division, which in the infrastructure division is where we've begun using the IoT model and the IoT devices to enhance our clients' ability to see inside their organizations and ability to use devices to be able to predict a little bit better how their organizations are functioning and why there might be some issues in their supply chain and some other stuff like that. We also are a cloud computer, cybersecurity. We're a full service managed IT, but we do have an infrastructure division that's focusing very highly on being able to integrate these products into our clients and manufacturing and into other areas also. So you can go on from there. I'll take the next slide. So what is a smart sensor? And the slide here is a little misleading because it talks about how great smart sensors can be. But basically, what a smart sensor is any device that both gathers data, communicate that data in real time or near real time back to your organizational database, back to some kind of a metric. So those devices can be anything from temperature sensors to GPS tracking devices to sensors that measure the oil levels inside of a piece of machinery or anything like that. And those smart sensors are designed to send data and information back to your systems in order for you to be able to make good predictive decisions, real-time decisions, or even in other cases, decisions that will change the way you produce in the future. So basically, the smart sensing technology, it has this ability, and we believe it's transforming whether we like it or not. It is basically the future of way all businesses do and predict their supply chains moving forward, their manufacturing, how well their facilities are functioning. We see it happening in our hotel clients and other areas where they know which areas are more likely to have people congregate around. So there's a lot of stuff, and it's a very generic term. There's lots of smart sensors. The IoT is a very kludgy term right now, kind of like cloud was to us going back 4 or 5 years ago. So IoT can kind of mean anything, but in the way that we're looking at it, we're really looking for sensors and devices that can either be retrofitted sometimes to the older devices that you already have inside your facilities and be able to send over that data back to some kind of predictive analysis system for us to be able to look at it and make good ideas. It's functioning about how a package was delivered from one area to the other and what kind of metrics or what kind of experience it had in between. So you can go on to the next slide. So, objects and the concept of sensors inside of a business, to give the example of where we're seeing this inside of almost every industry, from the manufacturing side of the house, we're seeing it. I'll give you an example as far as you'll see a product that we use after this for this example. Inside one of our large bread manufacturers, they were manufacturer bread facilities. They were experiencing issues with a certain product inside one of their freezers having an inconsistency in its density delivered to the clients, and they couldn't figure out why. And in the past, normally they would have one temperature reading, maybe 2 thermometers, but using this sensor technology, we were able to put in on the fly, pop in multiple sensors all over the entire facility and realize that there was a 10-degree difference from the more normal area where the sensors were being put all the way up to the top of the building. That was giving us a 10-degree difference. Now, these smart sensors were giving us real-time visibility into why a product might not function correctly along that inside their life cycle. So I'm sorry, there's a little background noise for that. So this was a real world where we see very quickly where a device that all it did was communicate over, in this case, it's Z-Wave wireless. So the connectivity doesn't really matter. It was a Z-Wave wireless solution back to a smart device. We were able to pop up multiple sensors in a short period of time to show this client why they were having some problems with their product moving forward. And they could now go back and take a look at and adjust the temperature or fix the facilities. So that's kind of the basics of where this starts, and then it moves forward into the ability to actually look into things like there are sensors on manufacturing equipment that say, this machine normally has a 3-year life cycle, but we see excessive wear in this product, and maybe we need to change it before the manufacturer's original, life cycle change, so that these sensors that are out there might find excessive wear inside products. It might find that one product is using oil quicker than another product. So we're seeing this across the entire gamut of industries for our business, where we could add in these smart sensors. Those sensors can be anything, like I said, from cameras to dry contact stores that are opened or closed, things like that. So it really covers everything across the gamut. And then all of that data and all that information, to really make it the Internet of Things, to really make it useful, what we see on the other side is delivered down to an area where we can now either real time or in retrospect look at that data and make good decisions about it. So now we're able to see stuff that we've never seen before inside a client's organization to help them better predict what's happening, better see their organization, better deliver products to their clients. And I'll give a more prime example. We're working with a company that I wish I had the ability to put them in this slide, but we just started working with them recently, a company called Tiger Tracks. And what they're doing is they actually are in the shipping model, adding a device that both is GPS censored, it has wireless, it has near field communication, and it has a spectrometer for reading the gyroscopes of the device. And they actually can tell from beginning to end of a shipping of a product, the individual box, how well it was treated along its shipment process. So from the point their product goes into this box until it's shipped over to the client, they can see how many G's it had. They can read it in near field communication when it goes through the packaging facility. They can watch it along the track to see where it is, not only where it is, but whether or not in a certain location in the country, and what the humidity and temperature was while that device was being delivered, all in one small product. It's a very interesting product moving forward that I think is going to something we're going to see moving forward. So all of that is really exciting in the industry, and I think everybody should be looking to try to take a little bit of advantage of that. I'll tell you, the one area where it's already being used is really in the pharmaceutical field very rapidly, because they're very worried about their specimens and being able to keep those specimens very accurately at the right temperatures, where the devices, where a degree or two could really mean a change in either the outcome of their product or even the loss of that product. So it has tons of applications, and so we can move over to the next slide so we can take a look at some of these sensors and what we're talking about here. So you see here, this is the product that we use inside the bread manufacturers, and the devices that you see next to the larger unit, those are what we pop all around the facility, and we're able to very inexpensively monitor inside this facility, every single specific points where we think there might be problems, and then we can take those off if we're done and we think everything's good and move them somewhere else. So it's very cost effective. There's not a lot of wiring involved. These devices communicate back quickly, and they give us so much data in order to make good analysis. And what you're seeing in the background over there is, some of the temperature sensing and metrics that we use. So, like we've already discussed, environmental monitoring, quality control, making sure that a product wasn't dropped or didn't get rained on, or during its process from your supply to somebody else's supply house, making sure that they're being treated well along the way, being able to monitor equipment and checklists. So this is an example of the device that we were using. It's a product from a company called Digi, that's SmartSense. We've been using it all over, a very, very successful product. And we then tie that data back into other information that we get. So we tie this temperature data back into other information about what the quality control testers might be seeing on the other side. So did we see a small dip in temperature that also was noticed on the quality control side? We were able to kind of compare those two together with the KPIs and metrics that come out of this stuff. So we can go on to the next slide. So this is a typical example of what we saw inside a specific client, noticing the temperature change over periods of time and day, and at certain locations. This is just the example of data that we're looking at to be able to make good decisions for our clients. And most people are starting to get used to, what they call, what we call, key performance indicators that we want to see that says this is how our product is going to perform well if all of these items are in the right track. So I think I have one more slide, and then we can talk about a couple things moving forward. So another example of a piece of machinery that allows us to show how many cycles are on this machine, what the total time on this machine is, when we can predict that this machine is next going to need this, so we can do better things of when we can predict downtime, availability of parts, using some of the other things that go on inside the industry 4.0. Let's not shut this machine down now, even though it probably needs to be serviced if the part's a week out. So we can start looking at that and kind of compare these things, or say, oh, we think this part's going to be going in a week. Let's order it a week ahead of time so that we're not just having to emergency shut down a facility. So, these are kind of things that we're looking at. There are caveats about these things, and maybe we'll get into them a little bit later. I don't want to cover too much time. I know there'll be some Q&A. Very, very exciting stuff going on. The use of sensors, it's going to be everywhere. Those sensors can be everything. The ultimate sensor in the future is the camera that we see moving forward, but from any dry contact, any kind of thing that can give us data that we can transmit back to systems to help us make good decisions moving forward for our businesses. So I think that's my time. I appreciate you guys coming out here, and I'm sure to have to take some questions in a minute.
Thank you, Chris. I appreciate it. Well, it's been actually very great for us to learn about the sensors and how it is actually affecting our life, and there is going to be more and more. That's what we understand. We've been talking about Industry 4.0, the concept. It is evolution in a way, and then we talk about predictive analytics and sensors. And how about the future skill set of the workforce? While we are changing our lives with the technology, with Industry 4.0, smart manufacturing, how it is going to be in terms of the skill set to fill the positions. So to this end, I like to turn it to Mark Agovina from Copper Tree Staffing Company, and we are looking forward to learning about it. Mark, would you like to go on?
Sure. Thank you, Kevin.
Thank you.
I appreciate that. So, Industry 4.0, very exciting time. We're blending the physical systems with new cyber capabilities to create this digital and smart manufacturing. So it's going to bring in some new skill sets to the existing workforce, as well as some new skill sets required in the technology. So next slide. Give you a quick background on me. I've been in the technology industry for about 30 years. I was a hiring manager before I got into recruiting and staffing, and formed my firm in 2009. Next slide. Basically, we help companies hire full-time employees as well as staffing services for short or long-term contractors. So we can skip the rest of this to the next slide. So this is a big undertaking. Obviously, we've talked about that. To give you some scale, in 2016, PricewaterhouseCoopers figured that companies across the globe were going to spend $907 billion a year for 5 years on everything from sensors, networking, new automated machines, but also including a lot of software and applications to do management, control, analysis of all new data we're creating. But it's going to include a lot of that is also training of existing employees and hiring of new specialists. And probably most importantly, I think, is driving all change. It's going to change the way we do business, right? So next slide. So there's a lot of different components of technology that are going to come into play here. additive manufacturing, 3D printing, the machining. They're already on the shop floor today, material transport systems, but a lot of new things are going to be introduced, robotic vision systems and artificial intelligence. And obviously, each of these systems requires the operators to be trained on those specific operating controls and parameters. There still requires people to be around to set them up, to program them, and to monitor. But there are a lot of new things that come into play as well. Next slide, please. So there are a lot of new buzzwords and kind of technologies that come into play here. We've talked a lot about the IoT, or Internet of Things, so sensors and connectivity and so on. The connectivity is in a lot of cases wireless, but also includes wired networks. So that's an area of concern. And a lot of software. Some things, again, we already see within our manufacturing environment. Supply chain software, ERP, and so on, but new things that we're going to be incorporating to do analytics and control, like Chris was talking about when we're looking at smart sensors. We can now analyze a lot of information, and then business intelligence, which gives us a way of making decisions and control based upon kind of literally rules and computer intelligence. And then finally, the cloud storage and computing that lets you now store this vast amount of data, analyze it, perform activities in environments that are not necessarily on our sites, but are in secure environments and can be shared across locations. Next slide, please. So let's talk about specific skills. Like I said already, need to train our existing employees not only to be a little bit more computer savvy, but also on the specific new equipment that we're going to be bringing into the shop floor. But beyond that, when we're talking about new skills that need to come in, perhaps from the outside, whether you're hiring some employees or hiring a consultant or outsourcing, cybersecurity to me is probably the most important and most pervasive. We need to, you've got now interconnected systems and data repositories. You need to protect against things like viruses and worms. We've already seen examples of manufacturing being shut down by the WannaCry virus a couple of years ago. Stuxnet was a worm that was let loose into the Iranian nuclear facilities probably 10 years ago now, that had, about 8 years ago, that had shut down things that didn't necessarily seem to be, computer SCADA devices and things like that you don't normally think of as being hackable, but now that we're interconnected, they can be. So it's perimeter security to prevent hackers from getting in and stealing data, as well as antivirus type systems to prevent kind of what's called a denial of service, or kind of an overflooding of the systems if somebody wanted to maliciously shut down your facilities. So we need experts that are going to be able to secure the networks and maintain that on an ongoing basis. Next slide. So the next thing we need are going to be what we call data scientists. So these are people that are not specifically programmers, but they are people that are involved in the analysis and the reporting on what's called big data. They're business intelligence systems that are involved in really that allows us to make kind of actionable decisions from data. We've got massive amounts of data that is coming in, so we need to then kind of create information out of that, and then from information, business intelligence systems gives us kind of actionable actionable information, I guess. But it is but it goes beyond that. So next slide, please. So networking obviously becomes an underpinning of this. We're now interconnecting everything. So we've got both local networks and those wide area networks. So the factory-to-factory connections, factory headquarters. Those are fairly standardized. So it's IP networking. It's network engineers skilled in things like Cisco and Juniper and HP. They're manufacturers. But the wireless will include both the Wi-Fi, which we're all pretty familiar with. We have it in our offices, we have it in our homes. But the new 5G wireless technologies are going to take that another basically 5 or 10-fold leap in terms of throughput. We need experts that can map out coverage areas within our factories and then enable not only the security but also kind of reliability and throughput wireless systems. The next slide, please. And so the fourth area that we see a lot of is dealing with software engineers, developers, programmers, whatever you want to call it, dealing with both packaged software systems, integration and extension of it could be large systems like SAP or other kind of ERP programs. It could be in the dealing with the integration of legacy and new systems together so that they're able to communicate. Operators who are able to design parts on them that can then be fed into CNC machining or 3D printing. And just in general, kind of developers usually using languages like Java and C++ to enable analysis and reporting of data, control systems, any kind of custom software that needs to now control the factory floor. Next slide, please. And then finally, the maintenance technician evolves as well. So these are the guys that keep the shop floor running. But now they're going to not only need to deal with equipment maintenance and repair, but they're also going to be handling networking in order to troubleshoot the new interconnected systems. So I think actually we're going to hear a little bit more about that in a few minutes. So next slide, I think I'm done. All right, so I'll close with a quote from Jeff Immelt. So industrial companies are in the information business, whether they want to be or not. The industry is changing, so we really need to incorporate a lot of the information technology processes, skills, and capabilities that are everywhere else in the industry today. So, and that's it. Thank you very much, Kevin.
Thank you, Mark. Well, it's definitely good to know what is coming and be prepared about it. That's very important for everyone in actually business. So that's vital and great insights. Thank you very much. Let's learn about predictive maintenance a little bit. And I'd like to turn it to Itiar Gonzalez, software engineer of Bimser International, to tell us about it and maybe show us about it, right, Itiar?
Yes, both, Kevin. So I have a few slides here about predictive maintenance, and it basically starts with the 3 types of maintenance that we can work with whenever we are like a manufacturing company, a distributor. And we see up here that there are corrective maintenance operations, there are preventive, and there are also predictive maintenance operations. So basically the difference is the level of insights that we get on each section. So for example, we have maintenance operations that are corrective whenever something breaks and we fix it after. And then obviously that's gonna show some load-on cost, but obviously it's gonna end up been a great risk, for our companies. So typically we start with corrective operations and then we move forward to preventive maintenance. And so this is what Chris was mentioning, about the life cycle that the manufacturers tell us, maybe this machine needs to be like checked every 6 months. Then we integrate those operations into our calendar. But obviously, what we're looking into now is the predictive analysis and being able to predict when certain pieces are going to break. So, for example, if we can predict some excessive wear, we can see that there's some excessive wear in some of the machines, or we can see that a machine is consuming too much oil, then that might mean that we have to change some of the spare parts, right? And basically, it's gonna mean an initial investment, of course, for every company that is introducing the predictive analysis. But in the end, you see here some numbers. So the ROI is gonna be 10 times bigger. You're gonna reduce the maintenance costs. There are companies reducing by 70% the number of breakdowns that they get. You're gonna reduce the downtime, and basically, you're gonna be able to increase the production in your factories. So let me show you now how we can perform that predictive maintenance. So first of all, we need to collect all that data. Then we need to process the data that we get, right? So we can extract some insights from it, and then we'll be able to know the health of the machine at this very moment. So we know that maybe a machine, it has like a vibration, right? And the range of vibration is not among the specified levels. So if it's out of range, we can start predicting what pieces are going to fail next, or what should we change, right? So we can perform that fault diagnosis. And these can be done in with more smart machines right now, but we can also install sensors in legacy machines like industrial robots or machine tools, stamping machines, just like you see on this slide. And Chris mentioned that too. Just by picking up all that information, we're basically going to be retrieving all of that, and we can come up with a predictive model that is going to maybe even create automatic work orders whenever we have to complete a maintenance operation. And that's basically what we see here. We're going to see that there are a few steps that we can go through whenever we go about doing predictive maintenance. So the first of them would be to design the predictive maintenance program. You have to discuss and quantify the benefits and goals, because maybe not every machine should be guided, from a predictive maintenance point of view. Maybe we have some machines that we can just go by using the corrective maintenance operation. So we have to make sure we know which type of maintenance is best for each machine. Then the next step would be to select that predictive maintenance technology. So maybe a vibration analysis is needed, maybe infrared thermography, maybe ultrasonic inspection, oil analysis. So there are going to be a few things that we can keep in mind here whenever we are doing predictive maintenance. The next step would be to obviously invest on a equipment monitoring solution, because it doesn't make sense to be able to get all of that information if we cannot process that, right? So for example, with a tool, with a program like Bheem, was developed by Bimser International, I'm going to be talking a little bit more later, we can get all that data and we can create and assign work orders automatically whenever the system receives data that is out of range. The next step would be to allocate the resources. So Mark was talking about how the new employees are going to have to maybe be trained on doing other tasks, right, that are going to save a lot of money and time to the companies. So we have to train those resources. Then we would have to coordinate those 3 different maintenance programs, right? We have to study the disruption caused by the equipment downtime, the material and labor costs, and then we can decide which is better, because maybe sometimes, if we perform preventive maintenance operations, maybe we are over maintaining our assets, and that's also costing us time and money. So we have to make sure we know which type is better in each situation. And then finally, the last step would be to utilize dashboards and reports so that we can access real-time data, we can access KPIs, and we can document all of those trending, like failures, costs, everything. And if we want to do this, right, there are products out there. We obviously are going to be talking about Bheem, and it's a modular product. So you see on this slide that we have a set of basic modules here on the left, and then some optional modules on the right. So basically, each company that is interested in any kind of asset and maintenance management solution, they're going to be looking at a product like this that can do asset maintenance, inventory management, maintenance management, and then personnel management too, because we obviously have to keep track of all the labor, right? So whenever one of our employees has to complete a work order, right, they're going to be able to record in the system how much time they spent on it, which materials they had to change, so that we can calculate the maintenance cost based on the labor cost, the maintenance cost, and the material cost too. And you see here on this next slide that a product like Bheem offers many different features. So, for example, it is modular, which means we can get the modules that we need, and not more, no less. And it also is flexible and scalable. So we grow with the company. For example, today you might have like 50 users using the system, and tomorrow you might need 1,000, and we're able to accommodate your needs. We also take advantage of EBA's workflow capabilities. So if you remember from the first presentation you heard today from Kevin, we have a product called EBA, which is a workflow and document management system. And with that product running underneath Bheem, we're able to design our own workflows, particular to each company. So for example, maybe whenever we create a work request that we have to assign to someone, we can follow different steps, right? Maybe we create a work request, then we assign it to someone, then our manager has to approve that maintenance operation, then you complete it, and finally, the cycle is closed. And each company is different, and we can accommodate their needs that way. We can design their own workflows. Bheem also has a reporting tool, so we can obtain reports automatically, and we can generate them automatically too. So this means that, for example, there are companies who need to access the same report every single day. And not only you're going to be able to access it directly from the app or from the program, you can also get it in your email. So we can generate them and send them automatically into our inbox. And finally, you see at the bottom of the slide the feedback that we get from current clients. So they've been able to reduce the maintenance costs by 15 to 20%. And there are some companies who have been able to reduce the number of failures that they were getting by 80%. And that is a little bit about Bheem. I'm gonna now switch my screen so that I can show you how Bheem looks like. Just a quick overview, not too long, because I know we're running out of time. So it's just to give you an idea of how it looks like. So what you see right now is that I've logged into Bheem, okay? And the first thing we see is this dashboard. This is customizable. Each company or even each user can see something different in here. So for example, me as a manager, maybe I want to see the list of companies. Maybe I want to see the worker operation times, different work orders grouped by type. Maybe I can see the maintenance cost, which is calculated based on the labor cost, the material cost, and the service cost. Maybe we can see, some graphs, pie charts, tables, everything. And these dashboards are also actionable. So, for example, right now we see, for example, the periodical work orders, right? Now we see the failure maintenance operation. So each user can access whatever they want in here. And I'm just going to show you, for example, the main menu here. We have the 4 basic modules that we were talking about before. We have the asset, the maintenance, material, and personnel management modules. And then finally, we have the system settings. And whenever we are working with a company that has a lot of assets, we can group them by location, so that if they have different branches, they're going to be able to have like separate sections of the system with a person responsible for each facility, for example. And I don't want to go over the whole system. There is a lot of information about this program on YouTube. We can send you also the links so that you can watch those videos. But I do want to show you how this graphical asset tree functionality can help us know in real time what is wrong with the system. So, for example, we see here that there is a layout of the facility. We see some assets, which are these dots that appear here. Right now, all of them are green, which means everything is fine. And if they turn red or blue, depending on the legend here, if they turn red, then that means that there is a work order that has been opened. If they turn blue, there is a preventive maintenance work order going on. So we can arrange the legend, and this basically allows the managers to know every single moment what is going on right now. So, for example, you saw that whenever I hover over one of them, we were able to access some information about it. So you see that this is one of the tracks that we have in the system, and if I were to click on it, then we would be able to create a work request directly from it. We can create an order. We can start like a failure maintenance, a periodical maintenance operation. We can see the history of that machine. We can see like the image of this asset, and this is basically going to help our customers be more proactive. They are going to be able to just by taking a look at this image to see what's going on in the system and access the information. And you see that we also have modules for the maintenance. So here is where we create our work requests, where we define our preventive maintenance plans, where we get all of that information about the vibration, the temperature that we're picking up from sensors. We also have a module for the materials, so we can get all of our inventory in here. We can start tracking where are our spare parts. And finally, under the basic modules, we have the personnel tab so that we can manage our resources. We can take a look at the calendar. We know who is working on what when. And I think that covers a little bit of Bheem. I just wanted to give you an overview, and we can move forward with the Q&A session. Thank you very much.
Thank you, Itir. Actually, very rich webinar for all of us in terms of Industry 4.0. So we have covered many different subjects. At the same time, of course, we have received various questions in chat box, in the public box, and also privately. I also received some of them. So I like to share these questions with our panelists. So the first question is security, about security. Maybe I can address, maybe Chris can address this question. Chris, so we talk about predictive analytics, and we talk about sensors, and we understand that we collect a lot of data through the sensors, right? So how about the security of these data coming from various sources through sensors? Can you address this security part of it?
Yeah. So from our standpoint, I mean, this is something, I will admit that we're still a little bit in the Wild West with across the board. And I was actually at a conference today discussing this and the ability for us to be able to manage, keep an eye on, make sure that all of these IoT devices are up and secure, and methodologies to keep them separate from our day-to-day networks that our computers rely on and that others rely on. So security is definitely going to be a challenge as people add more IP addressable devices that need to be patched and maintained and monitored. But I also think it's rapidly going to be taken care of too. The newer manufacturers, the better manufacturers of these IoT products are really starting to say, it's not right for us to put these products out there without some level of change. It's definitely something to keep an eye on, and Mark hit on it too, that there you do need some expertise, whether it's in-house or someone like myself who would come in outsourced to we use the same kind of stuff that we would use on your computers to start making sure that your devices are up to date, and that the manufacturers, when they put out patches or updates to these devices, that we're rolling them out in the same level that we would roll them out to your PCs. So it's an interesting concept. It's out there that yes, the more devices that we put on the network, the more we need to be concerned about how the devices are interacting. There are some strategies that we use with our clients now, talking about their wireless networks and other things. We specifically start to set up segmented networks just for their IoT devices. So we'll have new networks that are just for things like, could be smart TVs or cameras or other IoT devices, so that they are separate networks specifically that don't crosstalk with their servers and data and cloud services and stuff like that. So there are strategies that are coming out that seem to mitigate some of these problems. And at the end of the day, it's really, hopefully we have some good IT people to back us up, whether like I said, it's through a service like Mark has and finding some good people internally that understand this, or through contracting with a company like us that really takes the security seriously.
Thank you, Chris. We have another question, like it is for Roger. What is the difference between Industry 4.0 and IoT? Roger?
If Roger is unavailable, maybe I could help out, or even Mark could help out with that question a little bit.
If he can hear me. I see his microphone is on. Meanwhile, while we are waiting for Roger, please, Chris, go ahead. Thank you.
Well, I mean, obviously, the Internet of Things versus Manufacturing 4.0. Manufacturing 4.0, from our understandings, from our conversations, is really the ability to deliver products at a much more efficient, much more relevant level, a local level, compared to what we're delivering now in our industry. So the concepts that we've been talking about and discussing with our manufacturers is the ability to, in the 4.0 world, deliver the specific products that people need in short run batches, local batches, or even one per device batches in a less expensive, more cost-effective manner than the large global, shipping model that we have, where we put stuff over to China, gets manufactured, gets shipped over here. It's actually by using the manufacturing 4.0 and the new technologies, whether it be IoT or 3D printing or other chain supply management products that allow us to both deliver products more unique to our customers. One thing we've been talking about very specifically is the ability to deliver to our customers. If you have, instead of having a warehouse of products in the back that you put on the shelf when they run out, if somebody pulls and buys that product off your shelf, that it automatically sends to whoever the manufacturer is to build you a box of just those specific products, gets delivered to your office, and now you pack out that product. Much more efficient than opening half a case of stuff and putting it back in the warehouse. So that's kind of that. Now the IoT set is all of the sensors and devices that allow us to make that possible. The IoT would say the cash register that scans the device out, that then talks back to the supply chain, that then goes on. And so the IoT is the real physical, the connectivity of everything that's in your factory to be able to deliver the manufacturing of the future.
Sorry about that, guys. What Mark answered there was quite exactly the answer to that question, Kevin, in that there's really no difference other than the fact that IoT is kind of tailored towards the manufacturing process. Another example to what Mark was stating there, if you think a few years ago, truck drivers oil truck drivers used to stop at a gas station, take out the big long stick and put it down to see whether or not that station needed gas. Nowadays, you have smart sensors communicating back via the IoT scenario back to the supply chain, telling, giving real-time updates as to whether or not a particular station needs resupply or not. Therefore, you don't have a whole fleet of drivers driving around the areas, doing these sticking in gas tanks to see whether or not, they need refilling or not. But that's right on point what Mark answered there. Thanks.
Thank you, Roger. Thank you, Chris. So we got great answers for this question. Another question is about the talent that we'll need in the future. I think Mark. Mark, the question is, in terms of hiring new people in the future, as for the Industry 4.0 and smart manufacturing, do we need to hire a lot of people with new skills that you mentioned in your presentation?
Sure. No, I actually think that, like Chris had alluded to as well, so it's really a combination. I think you're doing training of existing employees, both on the shop floor and within your IT departments. You're looking to outsource to experts, whether they be a managed services provider or a consulting firm, or and then in other cases you are looking to bring on board core skill sets. It may be somebody in security, it may be more networking or software development talent, but it's definitely a blend. So this is not all a salary hit. This is a blend of suppliers training, some new hiring as well.
There is a follow-up question actually. So, how is supposed to be the hiring process? What we should be careful about while we are hiring?
Well, so obviously the idea of kind of the blend of skills to have information technology and the manufacturing environment is a little nascent, right? So it's still beginning. We're going to find a lot of people that have kind of both as their full expertise. I think it's important to find people that understand the skill sets very well, and you can train them, kind of teach them your own environments. Ultimately, you have to start with the end. So enterprise architecture really helps kind of define how these technologies are going to be rolled out and when, and you really have to build your hiring plan from that, and decide which kind of skills you're going to bring in. Ultimately, the labor market's very tight today, especially in information technology. So it helps to spread your wings. Don't put all your eggs in one basket. Look at alternative sources for finding employees as well.
Well, that's great. While we are running out of time, I think we are coming to the end of our webinar. Well, first of all, we put all the contact information of our panelists. So if you would like to continue this conversation, feel free to reach out to us via email or phone. We put all the contact information available on the screen. So that is important, I believe. This has been actually very informative. We talked about Industry 4.0, smart manufacturing, smart sensors, predictive analytics, and cloud ERP and predictive maintenance. And also on top of it, we also talk about the skill set of future workforce in the scope of Industry 4.0. So we covered a lot of subjects in this webinar, and we like to continue this webinar series in coming days. That is for sure, thanks to your interest and your support. While I'm ending this webinar, I'd like to thank our panelists for their insights and all the information that they shared. And I'd like to thank our attendees for their interest and for their support. We look forward to meeting in our coming executive webinars in the future. Thank you very much and have a nice day.